actually an in-situ assessment of lampricide toxicity to age 0 Lake Sturgeon. And I'd like to thank Jeff Slade as well for the introduction to looking at lampricides and how they're used as part of the sea lamprey control treatment program. So I'm not going to spend a lot of time on background for this, so we'll go through the first couple of slides fairly quickly. So as I said, and from what Jeff told you, that the lampricide TFM is obviously our key component right now for sea lamprey control in the Great Lakes. There's certainly been work done showing that non-target fish do demonstrate a wide variety of sensitivities to TFM, and obviously from the talks here we have today and other literature that's been published, we know that age 0 Lake Sturgeon are a big concern to this. So again, as was mentioned earlier, the original studies that were published showed that Lake Sturgeon, particularly those that were smaller than 100 millimeters, were susceptible to TFM and TFM niclosamide or granular bear, which is our main components of lamprey control. And this obviously caused concerns with the program itself, which, as Jeff mentioned, led to the development of what was called the Sturgeon protocol, which limited the TFM concentration that was used in the streams to about 1.2 times the minimum lethal or maximum lethal concentration. And again, moved the timing of lampricide applications to after August 1st, which was used from the developmented models, where sturgeon growth would be big enough to handle treatment at that point in time. But what we actually set out to do in 2008 was test this, because this had all been done in the lab up until this point. So we actually wanted to look at what happened in the field with age 0 Lake Sturgeon, and we wanted to look at the sturgeon protocol and what happened during a regular treatment, which was generally thought to be at that time about 1.5 times MLC. So our hypothesis was that for sturgeon that were smaller than 100 millimeters, they were going to be susceptible to TFM, but we expected to probably have better survival under the sturgeon protocol than we would in a regular treatment. So we used the Mississauga River, which is on the north shore of Lake Huron, right there. And we used this river because we had the opportunity to divide it into two different treatments. We had the upper river, which we treated using the sturgeon treatment protocol, and then we had a booster site where we actually ran the full treatment protocol from there down. So it gave us the opportunity to test both treatments in one river. And what we found, our methods, we used hatchery-reared age 0 Lake Sturgeon, and these were the same sturgeon that were used in the initial studies done in the lab. And the main reason for that is we didn't have the opportunity to collect a lot of age 0 Lake Sturgeon in the field to run this project. So for our treatment, we had 15 cages in each of the treatment sections. We had 5 fish in each cage, and these were actually just modified minnow traps where we screened off the end so the fish couldn't escape. And we had a control set of cages where we had 10 cages with 5 fish in each cage. So what we found in 2008 is we didn't have a survival difference between the sturgeon protocol and the regular protocol, and those cages we had in the control area. What we also found is we had really high survival compared to what had been predicted. We had 94% survival in the upper Mississauga, which was our sturgeon section, and in the control cages, and 93% in the lower Mississauga, which was our full treatment protocol. So again, very high survival compared to what was predicted. We also used sturgeon which were smaller than that 100 millimeter mark. The mean size was 78 millimeters, and our range was 57 to 101 millimeters. We didn't have any size difference among the 3 treatments, but what we did find was it did tend to be the smaller sturgeon that we had mortality in. Again, mortality was very low, but it was those smaller fish. So our conclusions from 2008 were we didn't really have a mass mortality event, which had been predicted based on the tank studies. Our survival was not statistically different between the 3 sections, and our overall mean survival was 94%. And we also had a successful treatment for lamprey control. So obviously this led to the question of why is there such a difference between what we just saw in the field and what happened in the lab? So we obviously wanted to expand on this because we also wanted to make sure that the Mississauga River itself, maybe it was an anomaly. We wanted to make sure that, or at least follow up on this and see what happens in other locations. So we used a collection of 9 other tributaries. We had a total of 10 treatments. We used streams in Lake Huron, Superior, Michigan, which gave us a variety of water chemistries and habitat locations. We used a mix of TFM and TFM 1% niclosamide treatments, as in 2008 we'd only had the opportunity to use TFM niclosamide. And again, we used the same strain of hatchery-reared sturgeon. So to give you an idea of where our study rivers were, we had 4 on Lake Superior. We had the whitefish at Kaministiquia, we had the Batchewana, and we had the Two-Hearted. We had 3 rivers on Lake Michigan. We had the Millicockins, the Sturgeon, and the Pigeon, and we had 2 rivers on Lake Huron, the Mississauga, and the Rifle, which we again divided similar to what we had done in 2008. The upper section was run as a TFM only, and the bottom half was run as TFM Niclosamide. And we also followed the normal treatment schedule of July to September, so it fit in with treatments that were already happening around the lake. So we also added a bioassay component in 2010 and 2011 because this gave us the opportunity to look at the situation in a more controlled method and add different concentrations similar to the lab toxicity test. And we had a 10-tank study. So we had concentrations ranging from 2.1 times the minimum lethal concentration to 0, which was our control. And when we set up the bioassay, tank number 5, or the middle tank, was used as 1.5 times MLC, which is what was going to be applied to the stream during the treatment. And again, we ran the in situ experiment where we had cages in the river with our larval fish. We had 20 cages in the treatment section and 10 in the control section with 5 fish in each cage again. So looking at the bioassay is generally run for 12 hours of full treatment strength, and then a 12-hour clean water period after that. So the tanks were checked every hour, any mortalities were removed, all the fish were measured and weighed. And in addition to that, we held all the fish that survived from one of those treatments for an additional 30 days back at the hatchery, just to determine if there was any mortality post-treatment. So I'm sorry, this slide's a little bit busy here, but this is the results for bioassay. So just to break it down, on the TFM side here, we were able to run 6 treatments: the Two-Hearted, the Millicockins, Sturgeon, Batchewana, and the Upper Rifle. On the Batchewana, we were actually able to conduct 2 bioassays. The trailer that we used had 2 sides, so we were able to run a second bioassay at the same time. And in the bottom here, the TFM Niclosamide, we had 4 different streams: the Kaministiquia, the Mississauga, which again was run similar to the Batchewana with 2 sections, the Pigeon River, and the Lower Rifle. So, and the bioassays were run between 5 and 7 days prior to a treatment, and they were run again between July and September. So we do have a variety of fish sizes. So looking at that, the size of the fish that we used ranged from a mean of 40 millimeters, so quite small, up to 99. So we tried to cover the full range of fish size that we see in the rivers during this time. So we had quite a bit of variety, which was good to see. Now, overall, our survival, and this is all the tanks with TFM, our overall survival ranged from 51 to 96%. But the key tank that we want to look at here is this tank number 5, and this is the tank with what we would estimate to be put out in the field during the test for the full TFM run within the next 5 to 7 days. Now, what we have for our overall survival, in 7 of the 9 tanks, we had 100% sturgeon survival. Now, 2 of those tanks on the Rifle River. Now, this is the TFM. We only had 20% survival, and in the Lower Rifle River, which is the TFM Niclosamide, was 0% survival. So those results were obviously of concern to us. The other thing we also want to look at is what happens with lamprey survival, because if we run a full treatment and we have great Lake Sturgeon survival, but we have also great stream lamprey survival, this is also a problem. So we had, in 5 of the 7 streams, we had 0% sea lamprey survival in tank number 5, which is what one would hope for. 2 of the tanks, we had 10% sea lamprey survival. The Kaministiquia had a little bit higher at 40%, but one thing that also concerned us was the Sturgeon River, where we had 70% sea lamprey survival in tank number 5, which would indicate that could be an issue during the treatment. Overall, what we found in 5 of our treatments here, now this one here, we did not have any sea lamprey to compare to, but overall what we found in 5 of the treatments, the Lake Sturgeon survival was significantly higher in our bioassays even than what was predicted by the work that was done by Bogart in 2003. So using the bioassay data, we actually went and recalculated, using the program R, the sea lamprey MLC tables, and we also calculated one at the LC50 for the Lake Sturgeon, which is what we didn't have any values for previous to this. And we compared it with the pH MLC, and this is the value that's actually based on Bills et al., and that is the pH tables that are used to actually set sea lamprey treatment calculations for the river. So that actually determines milligrams per liter what's going to be put into the river. So we actually had the opportunity to recalculate based on our bioassay data what they looked like for these streams at that time. And when we look at the Rifle River here, the pH MLC is actually quite a bit higher than what we calculated with our bioassay. So that could explain partly why we did have such an issue there. At the same time, when we recalculated the Lake Sturgeon MLC, or LC50, is higher now than the sea lamprey MLC. So that was interesting to note, and that occurred in both the TFM and the TFM niclosamide treatments. And the other thing that we noted, the other one that I mentioned, was the Sturgeon River, where we had very high sea lamprey survival, and again, high sturgeon survival in aquarium number 5. The table value for MLC that was used for this was 1.9. When we recalculated, it was actually 5.17. So there is quite a bit of a variety between what we calculated and some of the table values. But you're also going to notice that the LC50 for sturgeon is lower. So it is something to be aware of. Not every river has the same MLC and LC50. So it's something we do have to take into account for future treatments. So jumping now to what we actually found in the river. When we did our in situ work again, we placed the cages in the river about 24 hours before the treatment to give the sturgeon time to acclimate. They were left in for 24 hours post-treatment, so that would leave 24 hours before the treatment time of 12 hours or plus, and then the additional 24 hours. So on average, our cages were left in the river for about 60 hours. And on removal, of course, all the sturgeon were noted whether they were live or dead. Everything was measured and weighed and brought back in. So again, looking at our results, what we have here are the streams that we were able to do TFM treatments on. We had 7, and we had 3 that we ran the TFM niclosamide treatments on. The one thing you're going to notice here is the Pigeon River. When we did the bioassay, it was done as a TFM niclosamide. That was the original intention for that treatment. Due to water flow changes, they were unable to treat it that, so it was actually treated as a TFM treatment. So just to be aware of that. Again, what we have for our size range, fairly small fish ranging from 42 millimeters right up to the 98 millimeters, so under that 100 millimeter mark, but again, quite a variety of sizes based on the time of the year that the treatments were done. Now for our overall survival, what we have, our lowest value was 45% on the Pigeon River, up to 100% on the Two-Hearted River. So again, we did have a bit of a range of survival. On average, our survival was 80% or greater. The other thing to note is the Rifle River, even though it had been predicted based on the bioassay of 20% survival, we actually had 67% survival. And in the TFM niclosamide, even though it was predicted at 0% based on the bioassay, we actually had 64% survival. So in-field does seem to be a little bit different than the in situ or the bioassay work. So there is a little bit of variation that we still need to work on for that. Now overall, the other thing that we found was the sturgeon that had mortality were smaller than those that survived. This was statistically significant in 4 of the treatments. However, again, we still cover the full range of sizes here. We're looking at a mean of 36 millimeters compared to a mean of 42, mean of 68 compared to a mean of 72. So again, we're still using very small fish in both sections there. The other thing to note here is we don't have any controls for the Mississauga River. All of our control fish did perish. The Mississauga River is a regulated river, and all of the cages, both below in the treatment zone and above, are in regulated sections of the river. What we didn't realize at the time when we put out our controls is that the regulated portion above our treated zone, the water fluctuates quite drastically, and the water actually dropped 2 meters overnight, and all of our cages were exposed and the fish were left high and dry. So the value that we have here for length is based on those dried fish, so it is a little bit smaller than we would have had for fresh weight. So we didn't use that for the calculation, looking at survival differences between the control and the in-river fish. So there is a statistical difference between the survival rates of control fish and treatment, as we would expect under most circumstances your control fish to survive. So what we were able to do with our in situ data was look at a predictive model, and we had a total of 26 variables that we looked at, and of those we had 4 parameters that came out to be the best fitting, and that is stream alkalinity, whether or not the treatment is a TFM only, the concentration of TFM that's actually measured going into the river, and a control variable, and that was whether or not there was a control in the river. Now, under normal circumstances for a treatment, there is no control. So that was removed from the model, and our model for Lake Sturgeon survival for treatment is the intercept, the value here times by the actual concentration of TFM measured in the stream, whether or not it's a TFM only treatment, and alkalinity. Now when we look at that model, what we have is our prediction. As alkalinity increases, alkalinity does make a fairly large difference from what we saw in our treatments and with the model here. So on the left here is our predicted sturgeon survival, alkalinity on the bottom here. And this is a little bit different than what Jeff had mentioned. For us, what we found is TFM survival, when we're using TFM only, as alkalinity increases, it does decrease our survival, but when we add niclosamide, it actually even pulled it down a little further. So this is something we need to investigate a little bit further. Again, as Jeff mentioned, there's not many rivers that are such high alkalinity, but it is something to be concerned about. So overall, what we found, our bioassay survival rates, and this is looking at all of the concentrations, ranged from 51 to 96%. So again, a little bit higher than what was expected from the original lab work. Our mean survival size, now this is based on the river and the date and time of the treatment, it ranged from 49 to 99 millimeters for our mean size. So we had some fairly small fish that went through these treatments. Our bioassay survival rates, when we look at 1.5 times minimum lethal concentration and below, which is generally what a river is treated at, either 1.5 or less, that increases to 68 to 100%. For the fish that we held for an additional 30 days, we did not have any additional mortality, so this also works very similar to what Mike Wilkie had talked about with if there's going to be mortality, it occurs during the treatment and it's during that time period. So once you move past that treatment, we don't seem to see mortality in the fish. And looking at our in situ work, our survival ranged from 45 to 100%. So we did have some variability there. Our mean size for survival was 42 to 98 millimeters. So again, some fairly small fish survived during the treatment. So our overall summary is our survival of sturgeon less than 100 millimeters is higher than what was predicted by Bogart et al. So there is a little bit of a difference between what's happening in the lab and what we see in the field. And overall, our average in situ was greater than 80% for all of the treatments. Now the Pigeon River itself had less than 50% survival in total, but once we moved out of that initial application zone, our survival actually increased to 72%. And in 7 of the 10 rivers, we had greater than 80% survival overall. So though our treatment survival was significantly lower than the controls, which you would expect to have fairly high survival in your controls, and there is variability between the rivers, and that is something to keep in mind, overall their survival was better than what was predicted by the initial models. The other conclusion that we have is obviously there's additional work that's needed to look at this relationship between alkalinity and lampricides and H0 Lake Sturgeon survival in particular. So that's all I have, and we're going to hold questions.